Hello everyone, my name is José de Queiroz. I am one of the authors of the paper A Visual Analytics Approach to Facilitate Crime Hotspot Analysis, which we would like to present to you. This is a joint collaboration with Emanuele Santos and Creto Vidal from Universidade Federal do Ceará in Brazil and David Ebert from Purdue University, USA. Crime is an important subject to study because of its cost to the society. Huge financial losses, physical and emotional harms are among the problems that crime brings. One of the most important players in the fight against crime is the police, an entity that in recent decades has been criticized as being expensive and ineffective. But they are trying to change that strategy. For example, they've been trying to change from a reactive posture to a more proactive one. They are leaving random patrols to use scientific analysis. And they've been trying to reduce the number of officers. Some new techniques are now common in police departments, like community policing and problem-oriented policing. These two techniques are supported by hotspot policing, a technique that recommends identifying regions with a high concentration of crimes and the deployment of more resources there. Two important areas among police activities are criminal analysis and resource allocation planning. Both activities would benefit greatly from analysis based on hotspots. For these activities, police officers generally only have overly technical and time-consuming systems at their disposal, which ultimately leads to modest use. In our paper, we show other related approaches and discuss how they not fully meet the domain tasks and requirements. In our approach, we worked with two police departments in the USA and one police department in Brazil in order to identify a set of domain tasks that would have a significant impact on police operations and to develop a visual analytics solution named SHOCK, the one-shot comparison tool, to address them. In the paper, we also included two different real-world case studies to demonstrate that our system effectively supports the completion of the domain tasks. The domain tasks were defined based on observations of the police officers' meetings, where we identified the questions during the internal discussion of the problems. We checked and adjusted the findings through later interviews. So, let's see the domain tasks and the questions that have led to them. The first domain task is hotspot identification and comparison. It consists of identifying priority areas of relative importance, the hotspots, and comparing pairs that represent different periods. The questions involved in this task are: where are the hotspots? Where were the hotspots? What is the priority now? Should our resources move or stay? How much of our resources should be moved? The second domain task is hotspot evolution. It consists of tracking the hotspot over time using an absolute level of likelihood. The questions related to this domain task are there hotspot expansions? Are there hotspot contractions? Are there new hotspots? Are there hotspot disappearances? Are hotspots moving? How to evaluate an intervention? The third domain task is the multi-time analysis. It consists of identifying how crime is distributed in different periods of the day. The questions officers use to ask are: do hotspots expand, contract through the day? How does the crime vary in the shifts? The fourth domain task is the multi-type analysis. It consists of identifying how different types of events correlate with one another spatially. Typical questions involved in this task are: is there a correlation between drug abuse and thefts in this region? Where to place specialized teams? Where to place mixed teams? The fifth domain task is the multi-level analysis. It consists of identifying regions based on increasing levels of likelihood. The basic question is: how many resources should be allocated in each part of the city? During our 2-year collaboration with the police departments, we developed a visual analytics system that provides an interactive visual environment for encouraging data exploration. Users can visualize crime events in different ways, such as point maps, chorograph maps, and density maps, KDE and MSKDE. The maps are organized in layers and can be made visible or invisible using the layer control. Those maps are fully configurable. For example, the users can control color and transparency, point size and shape, line borders, etc. Also, our tool includes spatial and temporal filtering components for selecting the dataset to be analyzed, and an annotation component which enables users to annotate their findings and plans directly on the map. When officers started using our system to perform the domain tasks, we noticed that they spent a lot of time to complete the comparative analysis. Some spatial comparisons would sometimes take a lot of cognitive processing from the users. They would build separate maps and make computations inside their heads. After a careful analysis of the domain tasks, we identified that they would benefit from a surface comparison tool. So we developed a novel technique called SHOC, the one-shot comparison tool, to make hotspot comparisons in a more direct way and avoiding this cognitive overload. Let's see how SHOC works using as an example a multi-time analysis to see how crime is distributed in different periods of the day. Initially, the user selects the first dataset, choosing the type of event, the date frame, and the events that happen in the day. On the mask-ID component, the user sets the parameters: the cell size, which is related to the resolution and performance of the map, the bandwidth, which is the influence range of each incident, and the percentage of density, which is how much crime density will be included in the map. After plotting the first layer on the map, the user selects the second set of data, choosing incidents that happen at night. The other parameters are kept the same. Eventually, the user can change the color of the layer to provide better contrast. The user then presses the SHOC button and starts exploring the map. New layers were automatically added to the map. They can explore the map using the layers individually or in groups. As we can see, MSKDs can be superimposed with minimal occlusion, displaying immediate spatial variations to release the user from making any visual comparison. Everything is integrated into one frame, including hotspots, the base map, and annotations to facilitate printing and taking pictures. The system displays the difference and intersection of hotspots in a familiar oil diagram form to aid handling and interpretation. Stable regions are shown in solid light yellow polygons, and regions that experience changes are shown fully transparent with their original border. Similarly to the given example, we have identified combinations in parameters and datasets that help to solve all domain tasks. We will demonstrate that SHOC helps to perform the domain tasks in two real-world case studies. In the first one, we worked together with the Lafayette Police Department and the Purdue Police Department to track drug abuse in Tippecanoe County, USA. The police knew that the recorded number of drug abuse incidents was increasing, and they wanted to know more about how and where that increase was taking place. We performed Domain Task 1 and Domain Task 2. Based on the Domain Task 1 analysis, we could identify that from 2016, shown in blue, to 2017, shown in red, drug abuse is more concentrated in the downtown part of the city of Lafayette. Notice that the number of incidents almost doubled from 2016 to 2017, but the hotspot area decreased. The concentration is also confirmed by the increase in the threshold, meaning that the crime likelihood level on the red border is more than twice that on the blue border. Thus, we can conclude that crime increased and concentrated in 2017. Additionally, based on the Domain Task 2 analysis, we could recognize that areas with at least the same likelihood of the hotspots of 2016 expanded in 2017, and new hot areas appeared. The second case study shows an analysis of homicides and robbery in Brazil. In the DT3 analysis, we could identify significant differences in the distribution of robberies between the morning, shown in blue, and around noon, shown in red, when the hotspot moves from Zone B, a less developed area, to Zone A, a richer one. Officers have used the DT4 analysis multi-type to plan an intervention to prevent homicides and robbery. They defined and annotated using the system the green polygons as areas for patrolling from 6 p.m. to midnight. The DT5 analysis shows the crime density regarding homicides at two levels, 25% and 75%, to give indications about progressive resource allocation. The domain experts' feedback about our approach was in general very positive. Officers expressed excitement with the possibility of comparing on the same screen hotspots of different time frames or different kind of incidents. They considered that shock would have a positive impact on routine activities and that the annotation layer would improve communication and teamwork. They also made suggestions to improve the tool, such as to simplify the interface regarding the number of input parameters. Some of the limitations of our tool are with respect to input parameters. Officers have to set cell size, bandwidth, and the density percentage, which is not natural for some of them. Shock also computes polygons operations, such as intersections and subtractions, for two MSKD layers, and the resulting pairwise comparisons satisfy the requirements of the officers. In our experiences with them, visualizing more than 3 MSKDs at the same time is not recommended because of clutter. In this video, we showed a characterization and abstraction of the hotspot analysis problem into 5 domain tasks and presented Shock, a tool that facilitates performing the domain tasks by giving a straightforward way of making spatial comparisons using set-like operations on superimposed geometries. We demonstrate shock effectiveness in 2 real case studies that helped police departments on planning their preventive initiatives to fight crime. This was only a brief overview about our approach. Please read the paper for more details, and thanks for watching.